In chapter 3, we will learn three main topics: time response, steady state error, and stability. The reason we have to learn this chapter 3, time domain analysis and stability, because it is the platform for us to evaluate and assess the control performance of our system. To ring your bell, chapter 1, chapter 2, you have learned what is system about, and you have learned some techniques to model them. So before you go to improve your system, definitely you need a platform to understand how does your system or your model behave. So there is some certain performance index that we need to use to evaluate the system. Four main subtopics that we learn in this topic, which is block diagram. Block diagram is the shortened pictorial representation of the cause and effect relationship between your input and the output of a system. So as you can see from here, the figure A and figure B. So definitely this one is always the one you have seen, which is S domain. So we call this is the input and this is the output. So G is always a transfer function, or in certain time we call it is a gain. So output is the value of input multiplied by the block gain. Three fundamental arrangement of block diagram that we must learn. First one is the cascade. What we call cascade when we have one subsystem arranged next to the subsystem. So this relationship we call cascade. So how to get a transfer function when you have a system is arranged in this way, where the transfer function output versus input is multiplication of G1 and G2. Parallel arrangement is when you have the first subsystem and you have second subsystem G1 and G2 arrange parallel, and you see the arrow is go to one summing point, plus or minus, important is the summing point. So this arrangement called parallel. So the transfer function for a parallel system is G1 plus G2. Why plus? Because here plus, if today is negative, so G1 minus G2. So negative feedback system is, first, this is one feedback system, because when you look at the arrow, it's feedback, it's a loop here. And negative is because here is negative. If today here is positive, then we call it positive feedback system. So because it is negative feedback system, so here is the positive, because the default one is the 1 plus minus G1 H1. I believe you have seen this many times. So this negative system is negative feedback, so you use is the positive here. Next step, I would like to show you how do we derive this. See, it's the arrow is a feedback system. A lot of students sometimes they confused with the parallel system and the feedback system. So the only tips is always look at the arrow direction. So this is negative feedback because we have negative here. So how to derive this equation? U1, okay, write the simple and as much as equation you can get from your from your block diagram, sorry. So let's see U1 equals to R minus Y2. You can name every single signals before block and after block of your system. It will easier us to do some derivation. Then Y2 R and U1 Y2. So we know we need the Y and we need the R. So we already have R here. Then we definitely do not need Y2. So we see what we can do else. Y2 equals to, you can write Y2 equals to G2 multiplied with the U2, and U2 is same as the Y1, and Y1 equals to U1 G1 here. So now you substitute the Y1 to these equations. The y1 substitute this, and then u2 substitute to the first equation. Do this and this to this. Then finally you can get the equation. So y1 per r is r, you can move to here. So we derive it. Let's look at our first example. We need to determine the transfer function output versus input for this block diagram. So check the arrow, the arrow direction is a loop. So this is the positive feedback system. Then we have the block as this. So look at this solution. We name the G1 block. This is our G1 block. This is our G2 block, and this is my H block. So you identify clearly, and we know that to write the equation C per R is 1 minus here because it is the positive feedback. So next, let's get this G1, G2. G1, G2 is you just G1 block multiply G2 block, then you can get this block. Next, we try to get G1, G2 H. So G1, G2, we already have it here, then same. So 6 over S is the H, then lastly you get this. So C over R is, you write this and then solve some mathematically, finally you get your results. And next, characteristic equation. Remember, characteristic equation always come from the closed loop transfer function, and it is at the denominator, which is the 1 minus G1 G2H. If today your denominator is 1 plus, then here definitely is 1 plus G1 G2H. So this is your characteristic equations. Why I need to show this example again to you? Because we need these closed loop characteristic equations very much in the subtopic of stability when we want to build the Routh-Hurwitz table.